Hello and welcome to this session. My name is Dirk. I have the pleasure to run a team of very excellent system engineers in EMEA for Prisma Cloud here at Palo Alto. And before I joined Palo Alto 1 year ago, I've been heavily involved in many topics around containers and Kubernetes in my previous role as a product manager for OpenShift. And I had the pleasure to work with many different customers on implementing DevOps, and then later at the later stage of the adoption of those emerging technologies, also implementing a DevSecOps approach. And here at Palo Alto, we have a powerful product called Prisma Cloud, which features a lot of different capabilities in the area of what we call shift left security. And in this webinar, I want to walk you through a couple of things based on the experience we made working with many customers of implementing DevSecOps as a principle. But before we talk about the different capabilities and technical features, let me quickly recap a little bit what this session is all about, right? So while working with many customers, we realized that many of the customers are pretty much focusing on implementing DevOps as a principle. And there are a couple of paradigms which are part of DevOps as a whole, it's all about collaboration. It's about shifting left responsibilities and technologies. It's obviously all about automation, productivity, especially developer productivity, because time to market matters. But it also includes a couple of operational aspects such as observability and also the end-to-end responsibility on the developer side, specifically focusing on the responsibility across the entire stack and across the entire lifecycle. And many customers are struggling. They implemented quite successfully all those different DevOps principles, and then they struggled to apply security to the same thing. But if you step back just for a few minutes and then basically recap what are those requirements, then you might be able to figure out that it's not that hard to apply effectively the same principles also to IT security and all the different capabilities in there, right? So collaboration means that the security design of an application should be a collaborative effort, which also means uniting teams and the expertise between the security team, the dev team, and the ops team. Shift left obviously is even more important in the security space than it already has been for the application development as a whole, right? So it's not just the tools and the data which are shifted left, but it's really all about the expertise and the collaboration. And then automation, and this is the key part of this webinar here, obviously the same requirements apply to security as they do for the application. So security needs to be defined in a declarative way as code and then automated across the entire lifecycle. And from a productivity standpoint, of course, it matters that it's not just getting out results out of the security platform. It's really about providing reliable and especially actionable insights, and also where those insights are needed. So in the tools the developers are using today, and since we all know that we cannot fix every single issue we observed, it's also very important to have kind of a prioritization to really focus on the most critical things. And from an observability standpoint, yeah, so it's fairly easy to do it at the beginning if you're just starting to deploy a few assets, a few virtual machines, container nodes, and Kubernetes clusters. But obviously, it gets a little bit more tricky the more complex your landscape looks like. And then it might make sense that you use software and especially artificial intelligence or machine learning capabilities in order to automatically detect different things, including the assets, automatically protect them and stuff like this, to avoid that a human being needs to spend his time and energy on doing very stupid tasks at scale. And also from a end-to-end responsibility, it's very important to understand that you can add multiple additional lines of defense to minimize attack vectors, and those are evolving, right? So it's pretty important that those are changing over time. But if I look back on many of the customer projects I've been involved in, it seems to be a pattern that the majority of customers, when we started to work with them, they basically only applied a very few security principles to their software development lifecycle. So the majority of customers I've been working with, effectively, they applied some security best practices to the software development and to the deployment. They did some kind of image scanning, and they had some kind of perimeter firewall to protect the ingress point of an environment. But we as Prisma Cloud or as the security vendor, we believe that this is not sufficient, and it's obviously there's something we can improve. However, there is a reason why many customers are not going beyond those three, let's say, basic or starting points. And I will explain those reasons a little bit during these presentations. One of probably the biggest blocker is what I call the mirror challenge. So the 100 to 10 to 1 or 1 to 10 to 100 ratio. But also if I look back at the different reports or findings of different surveys the industry is doing. So let me just pick the Accelerate State of the DevOps report powered by Google. If I look at those reports, it's kind of obvious that the majority of customers made a lot of progress in the last 5 or 10 years in further automating nearly every aspect of the software development lifecycle. This includes the building, the testing, and the deployment. And all the emerging technologies, CI/CD tooling, Kubernetes, public cloud, all those new emerging technologies significantly help to increase the amount of automation. But still many customers are struggling in the area of security automation. And in this webinar, I want to give you a little bit insight of what you can do and how we can help you to effectively reach a higher level of automation in the security space. If I just break down the software development lifecycle in 6 different stages, then it typically starts long before you start writing code. It starts with the design phase. And in my humble opinion, this is the most important phase ever. And this is the most critical phase from a DevSecOps and collaboration perspective. And unfortunately, this phase is typically getting ignored in many customer environments. Why it's so important? It's very important that before you're even building or defining or building or developing your code and your application, it's very important to understand, okay, what are the options I have, both on the application architecture side, but also on the security side. So what are the capabilities of the security platform and how can I leverage those across my lifecycle, and especially then if the application is running in production. It's very important to shift left, not just a tool. So it's not sufficient to just throw a security scanning tool over the fence and then ask the developer to run it and use it. This is obviously not the goal. The specific challenge here is what I call the 100 to 10 to 1 challenge, which means 100 developers are typically meeting 10 ops guys and 1 security guy, which also means that the security team is typically not staffed to build and integrate everything which might be needed, but it's very important that the expertise of this single guy who is working with typically 100 developers is really leveraged in this early application design phase. And it's also also important to define from the very beginning that the application architecture also contains the different security aspects, preferably in an automated fashion. So we are talking about policy as a code, which means together with the application specification and the architectural building blocks, we need to define which security aspects are supposed to be used and how they could be automated across the lifecycle. And probably the most critical aspect here, and this is sometimes forgotten, is that not only the tooling decisions is made and the technology decisions, but especially the ownership and responsibility is pretty hard to define sometimes, which also means who is writing the security policies, who is approving those, and especially who is also getting alerted and then owns the remediation. Because the overall goal of shift left security means that you are shifting the security capabilities to the earlier stages of the life cycle to find and remediate those earlier than in your production environment. And this also requires that it's really clear who owns the remediation and who is getting alerted and informed and stuff like this. And on the right side, what you can see there is just one example we typically using in our demos, where we basically explain, for example, if you define your architectural building blocks, you define a web application, then you are aware that there is a web application and API security firewall you could use. Then it might make sense from the very beginning to define, okay, I want to use this in order to protect my web application. And the best way to do it in an automated fashion is to simply define the firewall policies or rules in a kind of a format like JSON or YAML. and then use this single file to automatically upload this into the security platform and finally test it. So basically the goal is not only to look at the capabilities and what the security platform can do, but also looking into the options of how can I automate this in a way that I apply the same principles to my code as also for the security platform. This is the whole policy as a code topic. And then in the next phase, in the build phase, obviously, this is the most critical phase where the majority of security risk and threats are supposed to be found. And this starts very early. So I worked with many customers who started to build software and then finally started to, for example, scan the resulting image, which is pushed already to the registry. But you can start way, way earlier. Right? So you can start already in the IDE directly, so long before you're even submitting your artifacts, such as a Docker file or a Helm chart or Kubernetes YAML or a Terraform template. Long before we're even storing those files and using them, you can already develop in the IDE, and the security platform should have capabilities in order to inform you, hey, this configuration you are going to submit contains a couple of risks, and we would recommend to remediate those, and this is our remediation. So already in the IDE, you can scan for security risk or potential misconfigurations very early. And the next step would be that if you submitted this as a Git commit, for example, then again, the security platform should be able to give you guidance again as part of the Git commit. Hey, what you are going to submit here contains a couple of misconfigurations. We would recommend to remediate them. And then, for example, you could already use the out-of-the-box permissions and RBAC controls within Git in order to define a role model, which, for example, says the developer can submit the Terraform template, but the security team needs to review and approve the PR. And then, of course, the security team can look at those misconfigurations and the other findings coming out of the security platform. And especially, I want to highlight that the scanning has to include all the relevant content types. So obviously, this includes the code and the binary and also the container images. But probably even more important are all the templates you're using, such as infrastructure as a code. As I said, the Docker file, the Helm chart, Kubernetes YAML, and especially the Terraform, because those files typically are developed once and then used more than 10 times. And this is what I call the 1 to 10 to 100 challenge. If a template contains a misconfiguration and is used 10 times, then at least it triggers 100, probably even 1,000 alerts in your production environment. And in order to avoid that, because it's quite hard to remediate 1,000 different alerts in your production environment, it's very important to remediate those findings as early as possible. And this would mean directly when you are developing those infrastructure as a code templates. And just from a risk perspective, those are even more important than just vulnerabilities in an image or stuff like this, because the infrastructure as a code template, such as a Terraform template, which defines the entire infrastructure, the cloud environment, all the configuration, the orchestration platform, and the application running on top of it, obviously there is a higher complexity in those infrastructure as a code templates. And that's why it's even more important to scan those compared with just doing some basic vulnerability scanning of the container images. And again, during the build phase, as you are developing the software itself, it's very important that side by side, you are defining or writing the policies as code and also the corresponding test cases, right? So you can basically define everything which is needed in order to protect the application. And you also need to ensure that whatever you are going to test during your pipeline in the next stage is also a valid test case and also submitted to the corresponding Git repository. And this also includes, you probably can apply a huge amount of different out-of-the-box industry standards, such as PCI, DSS, whatever, CAS benchmarks, and so on. But maybe you also want to define some custom compliance checks, which are really unique to your environment in order to assess, measure, and also to enforce your very own tailored security baselines. So you should combine all those different capabilities in your build phase, which is, again, the most important one. And then it's during the test stage, effectively everything you are doing with your application. Yeah, so you are doing an extensive testing from looking at it from many different angles. and you can do exactly the same with all the security capabilities. So typically what we do on a regular basis is running a very powerful demo, which shows you how to automate all the different capabilities I just outlined in a fully automated manner in a pipeline, such as Jenkins or GitHub Actions or Azure DevOps or whatever. It doesn't matter. We do support out of the box all the different pipeline tools. And since we are using APIs and CLIs, it doesn't matter which pipeline tool you're using. I just want to call out that it's very important that during the pipeline run, you should be able to verify all those different aspects, including the library scanning, the image scanning, the policy management, the infrastructure as a code scanning, web application firewall, all those different rules, that you are able to automatically deploy those and automatically test those as you are doing it for your other aspects. One thing I want to call out in this context, because many customers are pretty much focusing on vulnerability scanning, which is still important, don't get me wrong. I don't want to downplay it. But if I just look at the most recent attacks which happened in the IT industry, vulnerabilities is just one aspect, and probably even more important is malware detection, right? So don't be limited to just identifying outdated software packages in your software stack. Especially look at malware, especially if you're dealing with many externally sourced components, such as open source components, or you have a lot of supplier. Don't underestimate the risk that malware is contained in the binaries you are using in your software stack. And it's a little bit harder to detect those, especially if you look at the different maturity level of malware detection, if you compare different tools which are out there in the market. So for Prisma Cloud, we are using the Wildfire service, which is also used for the Palo Alto Next Generation Firewall, in order to do a bare metal analysis of malware. We unpack the stuff. We do have a multi-step in-depth analysis of the malware in order to have a higher ratio of findings to detect malware. And from a pipeline perspective, if you want to measure the success of the overall implementation, you can do this very easy, right? So because if you can automatically detect issues and then automatically those issues are reporting in the tool you're using, such as Jira or ServiceNow, then you can also start to measure the time to remediate. And again, it comes back to who is owning the remediation and who is responsible, and how good are those teams in order to remediate this pretty quickly, in order to ensure that still the time to market goals can be met. And from a security tool perspective, it's also important to understand there isn't just one pipeline or one application which is used in an environment. It's typically a huge amount of different teams working on different applications, using different pipeline, different cloud assets and stuff it is. From a security perspective, it's very important that you have the single pane of glass monitoring this across all the different entities in your environment, to have this overview, and then also provide guidance, identify the teams you want to invest further into trainings or whatever else. And this also comes along with the verification of the security aspects in the pipeline are supposed to happen by both the developer persona and the security team persona. And this also includes, of course, the different tools which are used during those stages. And then you're going to finally deploy the software. And this is something you can already test during the pipeline, obviously. I just want to call out that the majority of point-of-time scanning of images is kind of useless, in the sense of a point-of-time scanning already contains outdated information a few minutes later, right? Because vulnerabilities can occur at any point of time. So it's very important to map the vulnerability scan results to the runtime information. So which image is really used as part of one of your pods, and what are the new vulnerabilities or CVEs which have been detected in your running containers or pods, right? So this is pretty important, but it's even more important, especially for smaller developer organizations with limited security experience and capabilities and a high pressure on time to market and other things. It's very important that you have something which helps you to prioritize the mitigation. And that's why it's really important that you have kind of a scoring model, which really helps you to identify what is the highest risk, because it makes a huge difference whether an image contains a couple of critical vulnerabilities but isn't really used, and the software where the CVEs are associated with isn't even running, compared with an image which runs as a privileged container somewhere, and then the image is exposed to the internet and finally gets even access from malicious IPs from a different country you haven't expected any traffic from. And the risk score basically helps you to put the vulnerability scan results into a particular context. And this is pretty important. But if you need to prioritize and you cannot fix all the security risks which have been found, then of course it's also important that you can whitelist content either as an emergency fix, that you can exclude a couple of CVEs you are going to fix later, at least temporarily. But it's also important that you have some kind of mechanism that you can explicitly whitelist the trusted and approved content, which is supposed to be used, versus the content which hasn't been fully tested or verified by the security team. And then it's also important that if there are findings, then of course an alert is fairly easy, but it's more important that the alert can trigger various actions, such as doing a forensics in-depth analysis, or triggering or opening a ticket, or providing further information around the particular application in an additional tool such as CM, or in an additional SOA tool like Cortex SOA. Right, so this is very important. And then again, of course, it's also very important that the security aspect shouldn't be limited just to the application, right? So it needs to cover the entire stack, from the cloud infrastructure over the orchestrator up to the application running on top, including all the network access which coming from the inside and from the outside. And this makes it a little bit harder. And even more harder is it to find the runtime behavior of an application. So many customers are focusing really on all the static elements you can test during the pipeline or very early in the software development lifecycle. But if you look at the most recent threats and attacks, then you might notice that many of the issues, they do not occur immediately, right? So it takes a few hours or days until, for example, malware is starting to wake up and then start to do this malicious behavior. And then it's very critical that you have a runtime analysis of your application, which needs to be verified continuously. And you cannot do this manually. You rely on software which does it for you. And what really helps you is, for example, if the software can automatically create a model of what is the application expected to do, right? And then once the model has been defined, which is automatically done, then it automatically fires an alert each time the application is, or the pod is behaving differently compared with the expected behavior. And this is very important for the production and runtime information that the software is helping you there. And then it's also very important that the incident detection and prevention really happens based on the model and threats, and also includes an automated learning, and also leverage other services and further findings which are not coming from your particular environment, but are, for example, an aggregated result of parsing millions of log files from many different customers, and then identifying malicious IPs and access patterns and stuff like this. And it's also, I already mentioned it during the previous slide, the alert is more than just the alerts, right? So it's not just firing an email or throwing a Slack notification. The alert should help you to also integrate the information into different tools you are using, such as a SOA tool, such as Cortex SOA or something like this. And it's also very helpful if the tool can not only help you to detect something, but also to remediate something using auto-remediation capabilities to enforce baselines. This really helps you to scale, because the auto-remediation can happen already before or shortly after something is getting deployed. And this helps you to avoid that security incidents are even created, because the baseline enforcement happens as early as possible. And then, of course, thank you. And then, of course, it's more than just one single application and just a few assets. you need to be able to automatically detect new assets which are spun up, such as new hosts or new applications, and not only automatically detect, but also automatically protect those assets. This is very important. And then network activities, again, it really makes a difference if you have a pod which is exposed and then the pod is getting accessed by something you have never expected, right? And then don't underestimate the risk associated with some top attacks such SQL injections, shell shock, etc. There are plenty of different attack vectors, and you have also plenty of capabilities in the security platform to protect against those. So the web application firewall, for example, can help you or in combination with the data security offering to use the AI-powered services in order to detect malware or to detect malicious IP address access and so on and so on. And of course, this also comes along with a continuous improvement. So it's never a one-stop shop, right? So you need to continuously evolve all your security aspects as threats are evolving. Also, the security platform needs to evolve. New capabilities have been added. And then it's up to the security team also to help the development organization to understand what else can we use? What else can we do? How can we further protect our application? So what are the key takeaways of this presentation? First of all, identify threats as early as possible. The earlier you can do it, the more cost and efforts you can save in later stages of the software development lifecycle. And this really means starting in the IDE at every Git commit and every pipeline run. So the pipeline is effectively already kind of the last stage of where the majority of security risks should have been detected long before you're going to deploy the application into your production environment. Design all the aspects of your application, including all the security experts. And that's why it's pretty important to bring the security experts into the design phase. Bring them into the early grooming sessions where you are starting to define your application architecture, to let them review, okay, this architecture will allow me to do this and that, but this particular architecture, I have some concerns, but I can double click what exactly is missing there and how we can further protect this part of the application architecture. And then, of course, automate as much as possible. What we are typically doing in those sessions, we demonstrate how easy it is to automate this end-to-end workflow. You have seen the screenshot earlier from the pipeline where all those capabilities, so the Git repository dependencies checking, the image scanning, the malware detection, web application firewall, deployment and rule sets, the runtime defense, etc., all those aspects are tested in an automated fashion as part of the pipeline, which is very powerful. And the primary goal behind is really to reduce all the production risk and finding, because this is the most expensive way to identify security risk and then starting to remediate them. And of course, you need to have a way to prioritize and also to allow exceptions, such as emergency changes or break glass deployment. And then if you are able to leverage software and machine learning based services, do it, because this really helps you to identify threats you cannot foresee. So especially the unknown threats are pretty important here. And with that, many thanks for attending the session. I'm happy to hop on the launch after this session to answer all the questions which have been arrived in the meantime. I can't see any questions in the chat, but feel free to ask me anything if there are any questions.